Good morning, dear students. My name is Ferhan Mazher, and today is 15th March 2021. The day is Monday, and today the subject we are studying is Physics 5054. It's O levels physics. Today we have set our heart on solving May-June 2020 1-2 paper. It's a MCQ paper. We call it paper 1. This is zone 2. Okay, let's start this paper. On your screen, the first question: which quantity is a vector? Acceleration, distance, speed, time. Acceleration is a vector, distance is a scalar, speed is a scalar, time is a scalar. So I think A is the option. Let's check. Okay, on your screen we have question number 1. It says A is the option. Okay. Next question. Question number 2. The diagram shows the resultant R of a 3 Newton force and a 4 Newton force that act at a point P. The angle between the 3 Newton force and the 4 Newton force can be any value from 0 to 90 degree. Which value of the R is not possible? Which value of the R is not possible? Here they have shown two vectors, 3 Newton vector and a 4 Newton vector here, and the angle between them you can vary it from 0 to 90 degree. So I have done this on a paper. Let me show you. Okay, so here you see if the angle between the two vectors to be added is 0 degree, then those will be, the two vectors will be like this. They will be aligned with each other. They will be parallel to each other, aligned in the same line. So their resultant will be simply, you can get the resultant by adding them. 3 plus 4, 7 Newton. So if the angle between the two vectors is 0, the resultant will be 7 Newton. Then he says if the angle is 90 degree. Let's see. Let's say here I have tried to show a 3 Newton vector and a 4 Newton vector, and the angle between them is 90. Then I have used the parallelogram law. According to that law, if the two vectors to be added, if you put them in such a way that their tails are joined, then suppose that these two are the adjacent sides of a parallelogram, and then complete that parallelogram. So I have completed this parallelogram by these dotted lines. So the resultant will be where the tails are joined. Join that with the opposite corner of the parallelogram. That will be the resultant vector. You see, it's a right. If this angle is 90, this angle will be also 90. So this is 3, this is 4, this is 90, and I want this. This is a right angle triangle, and the hypotenuse of this right angle triangle is equals to the resultant. So I can apply the Pythagoras theorem. Pythagoras says that the resultant will be equal to the under root of the perpendicular square plus the base square. So 3 square plus 4 square, it will give you 9 plus 16, 25. 25 under root will be 5. So the resultant will be 5. So see, the maximum answer when the angle is 0 will be 7 Newton, and when the angle will be 90, the answer will be 5. So the resultant of these two vectors, when the angle will vary from 0 to 90, the resultant will vary from 7 to 5. So the answer should be from 5 to 7. There are the answers are possible. Any answer which is out of this range, that is not possible. 5 is in the range, 6 is in the range, 7 is in the range, 4 is not in the range. So A is the option. A is the option. Okay, next question on your screen. What is measured using a micrometer? Micrometer is used to measure the length. A area, B current, C length, D mass. So C is the choice. Micrometer is used to measure the length. C is the right choice. Question number 3, C is the right choice. Next question. The next question is on your screen. He says, yeah. Stopwatches are used to time the runners in a race. The stopwatches show the times recorded for the winner and another runner. So the time shown here, minutes, seconds, and hundredth of a second. Hundredth means 1 by 100. So the winner, his time is 57 seconds. So I will say 57.76 seconds. The other runner, its time is 1 minute 3.84 seconds. 1 minute 3.84 seconds. So let's convert them into seconds. So 1 minute means 60 seconds, 3 seconds further. So it will be 63.84 seconds. I have done this on a paper. Let me show you. So 1 minute 3 seconds and 0.84. So it is like 63 seconds, 63.84 seconds. And the next time is 57.76 seconds. So you subtract the 57.76 from 63.84, you will get 6.08 second. 6.08 second. I hope you have understood this. So B is the choice. Question number 4, B is the choice. Question number 4, B is the right choice. Okay, question number 5 is on your screen. Two cameras are unknown distance apart. The exact time that a vehicle passes each of the camera is recorded. What can be obtained from the information? We know the exact distance between them, and the exact time when the vehicle crossed the first camera and the second camera is known. So from the known distance and known time, I can calculate the speed. Average acceleration of the vehicle, average speed of the vehicle, maximum acceleration of the vehicle, maximum speed of the vehicle. We can calculate the average speed of the vehicle because the average speed is the total distance traveled divided by the total time taken. So I know the distance between the cameras, and I know the time taken for the car to move from one camera to the other camera, the second camera. So from there, I can calculate the average speed of the vehicle. So I think B is the choice. Let me check. Question number 5. Question number 5, B is the choice. A car of weight 11,000 Newton moves with constant velocity along a horizontal road. A driving force of 500 Newton acts on the car. What is the force opposing the motion of the car? You see, the car of weight 11,000 Newton moves with constant velocity. It's moving with a constant velocity along a horizontal road. When an object is moving with a constant velocity, the driving force and the resistive force, they are equal to each other. Because the body only moves with the constant velocity or constant speed if the resultant force is 0. The body will move with constant velocity only when the resultant force is 0. And when will be the resultant force 0? When the forward force and the resistive force, they will be equal to each other. So if the forward driving force is 5,000 Newton, the resistive force should also be 5,000 Newton. So the resultant will become 0. Acceleration will be 0. Vehicle will move with the constant velocity. So A looks the answer, G. A is the answer. Question number 6, A is the right answer. Question number 7 is on your screen. A man with an open parachute falls to earth at constant speed. The following forces act. The upward force of the parachute on the man, and the upward force of the man on the earth, the downward force of the earth on the parachute, the downward force of the man on the parachute. Which two forces act? Forces are a Newton's third law pair. Newton's third law pair forces, in the Newton, that third law, the forces should be in the opposite direction, plus they should be acting on different objects. For example, the body A applied force on body B, and the body B will apply force on body A. For example, the parachute applied force on the man, and the man applied force on the parachute. They can be the pair of the Newton's third law. So which two forces are a Newton's third law pair, where both the names are same? The upward force of the parachute on the man, the downward force of the man on the parachute. So P and S. P and S. C is the right choice. Let's check. C is the right choice. Question number 7, C is the right choice. You see the upward force of the man on the earth and the downward force of the earth on the parachute. The names has changed, so they cannot be the pair. So C is the right choice. Here the diagram shows the motorcyclist leaning over in order to turn the corner to the left. Which force causes him to turn? That is the centripetal force, and that force is always directed towards the center of that circle in which the motorcycle is turning. So because he's leaning in this way, so he's probably turning in this way. So the circular path here, its center will be in the direction of A. Its center will be in the direction of the A, so the resultant force must be directed towards the center of the circle in which that body is turning. So A is the right answer. 8A is the right answer. An object weighs 40 Newton on Earth. Its weight is 40 Newton on Earth, where the gravitational field strength is 10 Newton per kg. The object is taken to a planet where the gravitational field strength is 4 Newton per kg. Which row is correct? Okay, so if on the Earth you can find out the mass, if the weight is 40 Newton, you can find out the mass. W is equals to mg. So m will be equals to W by g. So 40 divided by 10, 4 kg. The mass will be 4 kg. When you take this object to the other planet, in that planet also, the mass will be still 4 kg. But there, the gravitational field strength is 4 Newton per kg. So there the weight will be W is equals to mg. There the weight will be W equals to mg. M is 4 kg and the g value on that planet is also 4 Newton per kg. So multiply 4 kg with the 4 Newton per kg, you will get 16 Newton. So B is the right option. I hope you have understood the calculation. B is the right option. Okay, I can show you my work also. I have done it with a different method. You see, I have found the value of the G in all the given options. This is a different approach. The way I have solved here, it's a totally different approach. You see, we calculated the G value for all the 4 options. The G is weight divided by mass. So in the first option, 1 divided by 4, so the G value is 0.25. That is wrong. The G value was 4 actually. So G is equal to W by M, 16 divided by 4, 4 Newton per kg. So that can be the answer. C option, 100 divided by 400, so 0.25. That cannot be the answer. D, W divided by M, 1600 divided by 400, 4 Newton per kg. So either the answer is B or it is D. Now, if I will take the same mass, let me, on the Earth, the weight was 40, the G value was 10. So for B and D option, I will calculate the mass value on the Earth. So if the weight is 40 and the G value is 10, then the thing will be 4 kg, and the weight is 4000, and G value is 10. The weight will be the M value will be 40 kg. So B, the two places here, the B is the best option. You should use the first methodology which I told you. The weight on the earth is given. The G value on the earth is, we know that. So divide the weight with the G value, you get the mass, that is 4 kg. So the mass will remain same when you go to the next planet or other planet. So either it's A or it's B. And we know the G value on that planet, that is 4 Newton per kg. It's given here, you can see this is given here. And then what I will do, at that planet, I will find out its weight. Weight is equal to mg. So if the mass is 4 and the G value is 4, multiply then a 16 Newton, the B is the option. And we have checked it already, it's right. This approach is easy. The one I showed you by working, that's little weird and difficult. Okay. So question number 10 is on your screen. The diagram shows the equipment used to determine the density of a liquid. Which equation is used to calculate the density of the liquid? Density of the liquid is the mass of the liquid, the pure liquid, the only liquid, the mass of liquid divided by the volume of the liquid. That's the formula. So how I will find the mass of the liquid? The mass of the liquid and the beaker. From there, subtract the mass of the empty beaker. You will get the mass of the liquid and divided with the volume of the liquid. So mass of the beaker and the liquid minus mass of the beaker divided by the volume of the liquid, that A is the right option, sir. Because the formula is mass divided by volume. A looks the right option. It's an easy question. A is the right option. Question number 11 is on your screen. Which single item can be used to find the center of mass of a plane lamina of irregular shape, a balance, a measuring tape, a micrometer, a vertical pin? Okay. A single item can be used to find the center of mass of lamina of irregular shape. We use a balance. No. A measuring tape? No. A micrometer? No. A vertical pin? If you know that experiment, you know we use a vertical pin in this case. So to me looks it's a little tricky, but D looks the option. Question number 11, D is the option. That pin is used to find out the center of mass. In that experiment, we use this. We also use the plumb line. A student makes a model toy which balances on the end of a metal rod. Why are the weights needed? They will lower the center of gravity. They will bring the center of gravity under the point of support. So they increase the pressure on the rod. No, they increase the weight of the model. No, they lower the center of mass below the top of the rod. Yeah. They raise the center of mass above the top of the rod. No. The center of mass should be below the point of support. And the thing will become very balanced. It will be very stable. Nah? They lower the center of the mass below the top of the rod. I think C is the option. Question number 12, C is the option, sir. Question number 12, C is the right option. Okay. Question number 13 is on your screen. An unstretched electric cord of length 15 centimeters stretches by 4 centimeters when a weight of 6 Newton is suspended from it. The chord does not exceed the limit of proportionality. What is the total length of the chord when the weight is 3 Newton? Okay. You see, when there is nothing hanging with the cord, the length is 15 centimeter. We call this L naught. We also call it unstretched length, L naught. So when you hung a load of 6 Newton, the extension is 4 centimeter. And he says, when I will hang 3 Newton load, how much will be the length? First of all, I will find out how much will be the extension. The length is equals to L naught plus extension. Let me show you my work. I've done this on a paper, and let me show you. Yeah, here we go. So the unstretched length is 15 centimeter. When the load is 4 Newton, the extension is, when the load is 6 Newton, the extension is 4. When the load is 3 Newton, how much will be the extension? You can use the, this is a mathematics technique, proportion, load and extension. 6 Newton load, extension will be 4 centimeter. When the load is 3 Newton, how much will be the extension? So 6 divided by 3 equals to 4 divided by x. Cross multiply 6x equals to 12. X will be equals to 12 divided by 6. X will be 2 centimeter. So when you will hang 3 Newton load, the extension in the stretch in the cord will be 2 centimeter. Now, what will be the length at that moment of the cord? The length will be L naught plus extension. L naught is 15, extension is 2. So the length will be 17 centimeter. This is a question on Hooke's law. I hope that you have understood. (17 centimeter). The D is the option. Let's check. Question number 13. D is the option. Okay, the next question on your screen. An object is placed at different depths in liquids of different densities. In which liquid and at what depth is the pressure on the object the greatest? You know, the pressure under a liquid, we can find that pressure, the formula hydrostatic pressure. We can find that the formula is pressure is equal to rho GH. Hydrostatic pressure is equal to rho GH. Rho means density of the liquid, H, G means the gravitational field strength, and H means the depth of the liquid above the point. The depth of the liquid above that point. Okay, so here the density is given and the D value is also, depth is also given. The rho value, the G value is 10 Newton per kg. So we can do the calculation and I can find the pressure for option A, pressure for option B, C, and D. And then we will see where we have the greatest pressure. I've done this on a paper. Let me show you. So here I think you can see in the first option, the pressure is equal to rho GH. For all the 4 options, use this formula. Pressure is equal to rho GH. The rho value is 1000, G value is 10. The H value for the different, for example, in the first option, we have rho GH 1000 was the density, the G is 10, the H was 4. So we got 40,000. And in the B option, we have 1000 multiplied 10 multiplied 10. So you got 100,000. And in the C value, you have 1200 is the density. Then 4 and 10, so you got 48,000. And in the next D part, the 1200 is the density, the G value is 10, and the H value is 10. You multiply 120,000. 120,000. So the greatest pressure is, I think, this D, 120,000 Pascal. D looks the best option. Question number 14. Let's check. Question number 14. D is the best option. I hope you have understood that how we calculate the hydrostatic pressure. That is rho GH. Rho means density and H means depth, and G value is 10 Newton per kg. Question number 15. A small vessel of volume 3 centimeter cube contains air at a pressure of 100 kilopascal. The small vessel is connected to a syringe. The piston is fully inserted into the syringe. The piston is moved slowly to the right so that the air in the syringe has a volume of 12 cubic centimeter. The temperature of the air does not change. What is the pressure of the air in the syringe? So the temperature is not changing. When the temperature is not changing and we are talking about a gas, so we can use the formula P1 V1 equals to P2 V2. When the P1 was 100 kilopascal, the V1 was 3. I don't know what is the second pressure, P2, I don't know, but I know that the V2 is 12 cubic centimeter. Let me show you my working. Go. So P1 V1 equals to P2 V2, and I know the P1 is 100 multiply 3 equals to P2. I want to know V2 is 12, so I will make the P2 subject of the formula, and it will be 100 multiply 3 divided by 12. The answer is 25 kilopascal. 25 kilopascal. 25 kilopascal. 25 kilopascal is B. So question number 15, B is the right option. Uh-oh, we have a problem. It says question number 15, A is the right option. Oh, we have to read the question again. We made a mistake. A small vessel of volume 3 centimeter cube contains air at a pressure of 100 kilopascal. The small vessel is connected to syringe. The piston is fully inserted in the syringe. The piston is moved slowly to the right so that the air in the syringe has a volume. Okay, so this is a vessel. Its volume is 3. And this syringe, when you move, the volume of the syringe is 12. So when this piston will move out, the air will have this vessel plus this syringe. So the total volume will be 3 plus 12. That will be 15. That's a famous mistake which we can make. Okay. So let me show you. Bring it here. Oh my God. I was about to make. So P1 and V1 will be equals to PV equals to P2 and V2. So I want to find out the P, the small p, I mean P2. So it will be PV and divided by the small v. Okay. So just put the values. Let's see. The capital, the P1 is 100 multiply. The V1 is 3 and divided by, now V2 is very tricky. You see, when this syringe will be, when the piston has moved out, the volume of the syringe is 12. I thought the whole volume is 12. So that's the mistake which you will fall also. And but the air will have this vessel and this syringe. The word is vessel and the syringe. So 3 and the 12. So it will be 15. The total volume will be 15. Okay. So the final answer will be 520. So this will be 20 kilopascal. So A will be the option. You see, we have made a mistake, and why we made a mistake, so you can understand that how we get how a student will make a mistake. Same, the way I make a mistake, the student is definitely going to make a mistake in the same way. You see, when you have moved this piston outward, the gas will have this vessel plus this syringe. So the volume of the gas will be 3 plus 12, 15. A very important question. So A is the option. Let me check. Question number 15. A is the option. So by making a mistake, you see, I hope that my students will be better able to understand that how a mistake can occur. Okay, this question is also very tricky. A rocket of mass m when empty carries a mass m of fuel. The rocket and fuel travel at a speed v. The engine of the rocket is fired and all of the fuel is expelled. The speed of the rocket increases to 2v. What happens to the kinetic energy of the rocket? He's talking about only rocket. It's a very tricky question. If you are attempting it first time, you might make a mistake. The rocket, he's talking about rocket. What was the initial velocity, kinetic energy of the rocket? And what is, after expelling the fuel, what is so you see the mass of the rocket is m and its velocity was v. So what will be the kinetic energy of the rocket? 1 by 2 mv. Simple. Then what happened? It expelled all the fuel and now is moving with the velocity 2v. Now what will be the kinetic? The kinetic energy equals to 1 by 2 m bracket 2v bracket close whole square. Let me show you. I have done this on a paper. Oh, sorry. Let me show you that. Okay. So you see, one thing is very important, and I always tell my students that whenever you are working on physics, we are never going to attempt any question whose answers we don't have. And that's why we always work on only those questions whose answers we have with us. So if you make a mistake, then if you check the answer, so you know that we have made a mistake. So initially the kinetic energy of the rocket will be K, kinetic energy equals to 1 by 2 mv square. Its mass is capital M and velocity is capital V. He's only talking about the rocket, not the fuel. So the kinetic energy will be 1 by 2 mv square. So, and then in the second situation, what happens? The rocket mass is still m and the rocket is moving at a speed of 2v. So 1 by 2 m will be m, but the velocity is 2v and the square of the velocity. So when you take the square of the 2v, it will become 4v square. So take the 4 to the side and 1 by 2 mv square, that was the initial kinetic energy, the kinetic energy which was in the first situation. So the new kinetic energy is 4 times the old kinetic energy. So the new kinetic energy will be 4 times. 4 times. Let me check. What happens to the kinetic energy of the rocket? It doubles, it halves, it increases by a factor of 4. It stays the same. C looks the right option. It increases by a factor of 4. Let me first check the answer. Then question number 16, C is the right option. In this question, the problem is with the way he's telling you the story, and you have to, you see, this question will trap many students. They will make a mistake because he only asks you to compare the kinetic energy of the rocket. Only the rocket, not the fuel. Next question, question number 17. A car of mass 1000 kg is driven 200 meter up an incline so that it rises 50 meter vertically. The acceleration of the free fall g is 10 meter per second square. What is the gain in the gravitational potential energy? Gain in the potential energy is mgh, where h means the vertical height gain. That's 50 meter. Let me show you my work. So gain in the potential energy is equals to mgh. M is 1000, g value is 10, and the h value is 50. The vertical height gained. So 500,000 joules. 500,000 joules is the answer. 500,000 joules. So C is the option. Question number 17. C looks the right option, sir, and C is the option. Question number 18. In which situation is the energy being released by the fusion of hydrogen nuclei to form helium? Fusion. What is the meaning of the fusion? In the fusion, you see the smaller nuclei, they come close to each other and those nuclei fuse with each other and they make a larger nucleus. For example, two hydrogen nuclei, they come close to each other, they fuse in each other, and they make a larger nucleus of helium. We call this process fusion, and this is happening on stars, this is happening on sun. Enormous amount of energy is given out. In which situation is energy being released by the fusion of hydrogen nuclei to form helium? It's happening on sun. In the decay of carbon-14 used to detonate an object, that's wrong. In a radioactive isotope emitting alpha particles, wrong. In the center of the earth, no. In the center of the sun, yes. This process is happening in the center of the sun. You see, this is happening in the center of the sun. So D looks the right option, sir. Question number 18, D is the right option. Question number 18 was D. Yeah. Question number 18 is D. Question number 19. The main stages in the operations of a coal-fired power station are listed. They are not in the correct order. The first one is the turbine turns the generator, water in the boiler becomes hot, steam turns the turbine, burning coal produces thermal energy, the magnetic induction produces electric energy, steam is produced. Okay. You see, so what will happen first? So first of all, we will burn the coal. So the coal will produce the thermal energy. Then the water in the boiler becomes hot. Second, then the steam is given out. The steam is produced. Number 6. After 4, 2, we should have a 6 here. Steam is produced. Then that steam turns a turbine. Then I should have 3. 6, 3. And the turbine, the steam turns the turbine turns the generator. So 1, and electromagnetic induction produces electric energy 5. That is the correct order. 6, 3, 1, 5. 6, 3, 1. So A looks the right option. Let me check. Question number 19. I think A is the option. A is the option. You see, this question is, what will happen in a coal? Let me reduce the size so you can see the whole thing. You see, first of all, the burning coal produces thermal energy. Water in the boiler becomes hot. Steam is produced. Steam turns a turbine. The turbine turns a generator. Electromagnetic induction produces electric energy. This is what happens inside the generator. So A is the right option, sir. Now, question number 20 is on your screen. In which situation is there no transfer of energy? A car battery turning the starter motor, a car moving along a horizontal road at constant speed, yes. A solar panel warming water, a spacecraft orbiting the earth at constant height. In which situation is there no transfer of energy? A car moving along a horizontal road at a constant speed, you see, and a spacecraft orbiting the earth at a constant height. There will be no transfer of energy taking place. D is the best candidate for that answer. You see, D is the best option. Why I'm saying D? Because the spacecraft orbiting the Earth at constant height, in the space there will be no friction and no energy will be lost. And so I think D is the best option. Let me check. Question number 20, D is the best option. It's a little tricky question. It's a tricky question. The 200 volt battery of an electric car is charged with the current of 33 ampere for 4 hours. The efficiency of the charger process is 90%. How much usable energy is transferred to the battery? Okay, let me check. I've done this on the paper. Okay. So, you see the input energy is IVT. I is 33 ampere, V is 200 volt, and the time is 4 hours. So I will convert it into second. If you want to convert hours into seconds, so you multiply it with the 3600. So the answer will be 950400000 joules. The useful energies will be only 90% because it's only 90% efficient. So 90 by 100 multiply input energy. So 90 by 100 into 950400000. So your answer will be 855360000 joules. So it will be something like 85.54 into 10 raised to power 6 joules. And 10 to the power 6 means megajoules. So it's approximately 86 megajoules. It is only 90% efficient. So whatever is in the input, the output is 90% of the input. I hope you have understood. So what was the answer? 86 megajoules. 86 is B option. Question number 21. B is the option. In an experiment to measure the power output of a small steam engine, a known load is lifted by the engine. Which two measuring instruments are also required? Measuring cylinder and thermometer. Why? No measuring. To measure the power, I need to know the work done and I need to know in how much time you did that work. Work done and the time is should be known. So work done can be calculated by knowing the force, the weight, and the height you gained. And the time can be measured with the help of the stopwatch. Which two measuring instruments are also required? Measuring the cylinder and the thermometer? No. Measuring cylinder and the meter rule? No. Meter rule and the stopwatch? Yes. I think C is the best option. Question number 22, C looks the best option. Okay. The next question. Okay. 4 metal containers with identical dimensions are filled with water at 90 degrees centigrade. All the faces except one of each containers are covered in a very good insulator. The one exposed face on each container is painted either black or white. In which container does the water cool the fastest? The water, because here we will have the hot water in the container, and so the temperature of the container is higher and the temperature of the surrounding will be lower, so it will be losing heat to the surrounding. So the paint should be black and it should be a large face and it should be painted black because black will be a very good radiator. So in which container does the water cool the fastest? where the radiator will be very good. And the black color is a very good radiator and it should have a larger surface area. So A, A looks the best option. 23A looks the best option. G. The A is the best option, sir. A little tricky question. Question number 24. Thermal energy used to turn water at 100 degrees centigrade to steam at 100 degrees centigrade. So it's purely change of state. Which of the following occurs? The force between the molecules decreases, the speed of the molecules increases, the separation of the molecules increases. You see, when you convert water into steam at 100 degrees centigrade, the forces between the molecules decreases. Yeah. The speed of the molecules increases. No. If the speed of the molecules will change, the temperature will change. So, and during, when the state is changing, the temperature do not change. It means the speed of those particles do not change. Very important fact. So 2 cannot be the answer. Separation of the molecule increases, that's true. So 1 and 3 only. I think C is the option. Question number 24. C is the option. Yes, at 24, C is the right option. A thermal energy produced by an electric heater in 3 minutes is used to melt wax. The solid wax is initially at its melting point of 60 degrees centigrade. It's already at its melting point. The specific latent heat of wax is 220 joules per gram. The heater supplies 7,700 joules of thermal energy to the wax. Some of the wax melts. How much wax melts? Whenever the state change is taking place, I can use this formula. Let me show you. When the state change is taking place, we can use the formula heat is equals to ml, where m means mass and L means the specific latent heat. So if I want to find out m, the L will go on the other side and it will divide. So m is equals to heat divided by L. The heat given by the heater is 7,700 and the specific latent heat is 220. So just divide this on the calculator, you get 35 grams. So 35 grams water will convert into steam. D is the right option. Question number 25, D is the right option. Question number 26 is on your screen. What always happens when the temperature increases? A gas at constant pressure expands. Yeah. When the temperature will rise, the volume will also increase. A metal rod becomes longer, but its volume remains constant. I don't think its volume, I think, increases. A liquid contracts and then expands. Why it will contract? The hole in the center of a metal disc becomes smaller. Oh, it's a very tricky question. You see, conceptual thing. A gas at constant pressure expands. That is true. If you will, you know that it is when the pressure is constant, and you're talking about a gas, then the volume and the temperature, they are directly proportional to each other. So when you will increase the temperature, the volume will increase of the gas. A gas at constant pressure expands. Yeah, that's true. So A looks the right answer. Question number 26, A is the best answer. The other options will confuse you. Which two rows explain why a liquid has a fixed volume but does not have a fixed shape? The forces between the molecules in the liquid, they are definitely large. The movement of the molecules in liquid, they are free to move within the liquid. They vibrate. So why they have a fixed volume? Because the forces are large, very large, the intermolecular forces. And why it does not have a fixed shape? Because they are free to move within the liquid. The particles or the molecules of the liquid, they are free to move within the liquid. A looks the best option. Question number 27. A is the option. The air in a sealed can is heated. The air in a sealed can is heated. You know the volume cannot change. Which statement explains the increase in the pressure inside the can? You know, when the temperature will rise and the volume cannot increase or decrease, you can say. So what will happen? The molecules, they will start moving faster, and when they will hit the walls of the container, they will exert larger force, and the collision frequency will increase. The molecules collide with the walls of the can more frequently when the air is heated. That is true, 100% true. The mass of the molecule is greater when the air is heated. That's wrong. There are more molecules per unit volume when the air is heated. That's also wrong. The separation of molecules become greater when the air is heated. Yeah, but that has nothing to do with the pressure. So explain the increase in the pressure. So that is because the molecules collide with the walls of the container more frequently when the air is heated. So I think A is the choice. Question number 28. A looks the best option to me. Okay, so next question. The diagram shows how the height above the ground of a rope transmitting a wave varies with the distance from the source of vibration. So on the x-axis, we have represented distance, and on the y-axis, we have represented the height. Okay. So you can see, this is the mean position. At 40, we have the mean position. So question is, what is the amplitude of the wave shown? The 40 is the mean position. So check how much high it went. It went up to, you see, 74. Yeah, 74. From 40, it went up to 74. At 40, I have the mean position. So from 40, it went to 74. So it means 74 minus 40, 34. So the amplitude of the wave is 34. Amplitude of the wave is 34. Let me show you the whole question. The amplitude of the wave is 34 from the mean position, how high it went. That maximum height is known as the amplitude. So here, from 74 minus 40, because the mean position is at 40. So it's 74 minus 40, it will be 34. So to me, B looks the best option. Let's check. B is the right option, sir. Question number 30. A vibrator produces 12 wavelengths on the surface of water in 10 seconds. The spacing between the first crust and the third crust is 60 centimeter. What is the speed of the wave? 12 wavelengths in 10 seconds. Okay, let me show you. I have done this work on a paper also, so you can understand. Here you see, I have shown a transverse wave. This is the first crust, second crust, third crust, fourth crust. They say the distance between first crust and the third crust is 60. So from first crust to this first crust to one second crust, it will be one wave. From second to third, it will be two waves. So there are two waves in 60 centimeter. So one wave will be of 60 divided by 2, 30 centimeters. So one wavelength, lambda, wavelength is 30 centimeter. The frequency is number of waves divided by the time taken. So there are 12 waves in 10 seconds. So it will be 12 divided by 10, 1.2 hertz. You know, according to the formula, V is equals to F lambda. V equals to F lambda. F is 1.2 hertz and lambda is 30 centimeter. So when you multiply F and lambda, the answer will be 36 centimeter per second. It will not be meter per second because the lambda we have taken in centimeter. That's why the velocity will be also automatically centimeter per second. I hope you have understood this. What was the answer? 36 centimeter per second. So where is the answer? C. Question number 30. C looks the best option. C. The diagram shows a ray of light incident on the boundary between two mediums W and X. The mediums have different refractive indices and indexes. Some light is reflected and some passes along the surface between the two mediums. Angle Y is the greater than the angle Z. Which statement is correct? Okay. So you see here we have one medium W, the other medium is X. The light was traveling in the X, and when it entered into the second medium W, it started moving at the boundary. It started moving at the boundary of the W and the X. So the angle of refraction here is of 9. This angle of refraction, that is 90. So this phenomena. This is about, you see, this is going towards the total internal reflection. This phenomena is getting near to the total internal reflection. So you see here some light is traveling on the surface. Okay, some light is reflected and some passes along the surface between the two mediums. Angle Y is greater than angle Z. Which statement is correct? You see, this must be a dense, because the process of total internal reflection is taking place. So this medium should be dense and this outer medium should be rare. The refractive index of the X should be greater than the refractive index of the W, because this phenomena only happens when the light is entering from a dense medium into a rare medium. So the refractive index of the X should be greater than the refractive index of the W. So he says W has a greater refractive index than X. That's wrong. W has a greater refractive index than X. That's wrong. A and B is totally wrong. C option. X has a greater refractive index than W and the angle Y is equals to the critical angle. No, angle Y is not critical. D option is X has a greater refractive index than W and the angle Z is equals to the critical angle. That's wrong. Yes, let me take this diagram. You see, one thing is very tricky happening here in the sentences. Let me show you a very interesting thing here. I missed one point, and now I will show you. You see, this is the total internal reflection taking place, and this, sorry, let me take the pen. So this is the angle of reflection, and this will be the angle of incidence. You know the angle of incidence and angle of reflection, they both are equal. Angle of incidence and angle of reflection, they should be equal in the total internal reflection. And this angle of incidence in the dense medium, its angle of refraction. I'm talking about now this angle of refraction, that is equals to the 90 degree. The angle of incidence in the dense medium, whose angle of refraction in the rare medium is 90 degree, that angle of incidence is known as critical angle. So this is the critical angle. This angle is this angle, this angle, this is critical. And I know that this and this is equal, so the critical angle is equals to y. So the critical angle is equals to y. Now I'll read the statements again. He says x, I'm just looking at the C option. X has a greater refractive index than W, that is a must for the total internal reflection. The light must be traveling in a dense medium, and from there it should enter into a rare medium, then the total internal reflection can take place. So, and the angle Y is equals to the critical angle, that is true. I just showed you that why I'm saying that the Y is equals to the critical angle, because this angle of incidence and this angle of reflection, they should be equal. This angle of incidence is called critical angle because here the angle of refraction is 90 degree in the rare medium. So this angle of incidence in the dense medium will be known as the critical angle. So the value of the critical angle will be equals to this Y value. Very, 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 I mean, you can see, tricky question. C looks the right option. Question number 31, C is the right option. It's a star question, you know. Okay. Again, here we go. Light enters a glass block at an angle of incidence I, and it produces an angle of refraction R in the glass. So light is entering from air into the glass. Several different values of I and R are measured, and a graph is drawn, sine I against sine R. So here you see, let me take this and show you on the, I want to show you that how this is done actually. Let me copy it from here and show you this on the in the paint, and let's find out how we do it. New discard paint. See. So what I will do, I will try to find out the slope of each graph. The slope of these graphs is equals to the refractive index of the glass. The slope of these graphs is equals to the refractive index of the glass, and the refractive index of the glass will give you, you know, it will give you the, because it's glass, its refractive index is more than 1. So let me take a point here. See how I do it. Because straight line. You see, if I take this x value as 0.5, the y value will be 0.7, 0.8. I've done this on a paper also. Let me show you that also. Okay. So the slope for the first, I have taken the value as 0.6. So 0.6 divided by 0.5, the answer will be 1.2. That looks the right answer. The slope is positive. The slope is more than 1. That can be the refractive index of the glass. Now, the next thing, this is not the answer. It's not the possible answer. The B cannot be the answer. Why? Because the line is coming downward. So this slope will be negative. So the refractive index cannot be negative. So B is not the option. C is also not the option because the slope here is negative. D can be the answer. So let's check. Let's check. Let's check. Let's check. I take this 0.5. I take it and I go to the graph. Okay. From there, I will draw a horizontal line. So if I take this point, its x value is 0.5, the y value is something 0.3 or 0.4, I think. I've done this on a paper. Slope for the D, 0.3 divided by 0.5 equals 0.6. But this slope, this represents the refractive index of the glass. 0.6 cannot be the refractive index of the glass. The refractive index of the glass is more than 1. So I think A is the right option. You see, one thing more. You see how I find the slope? This is rise divided by run. So how I find the slope of this line here? Rise, this is rise 0.3, 0.4 something, divided by run, that is 0.5. So rise divided by run, that gives you the slope, because on the y-axis we have sine I and on the x-axis we have sine r. So when the y is sine I and the x is sine r, so when I take the slope, when I take the rise divided by run, that gives me sine I divided by sine r, and so the value of the slope is equal to the refractive index. So A is the right option because this slope is more than 1 and this slope is positive. D is another candidate for the for the options, but you know its answer is not right because the slope is positive, no doubt, but the value of the slope is less than 1, so it cannot be the refractive index of the glass. So A looks the right option, sir, to me. Question number 32. Question number 32, I think A is the option. Question number 32, A looks the right option, sir. Let's check. Question number 32, A is the right option. Okay. The next question, question number 33, a converging glass lens. A converging glass lens. Okay. A converging glass lens is used to produce a virtual and magnified image. Which ray diagram shows the rays passing through the converging lens? Okay. You know, in the converging lens, the virtual image is formed if the object is inside the focal length, like in the magnifying glass. If the object is inside the focal length of the convex lens, converging lens, then converging lens, then the virtual and magnified image is formed. So A and C cannot be the options. Why? Because they are concave lenses, they are diverging lenses. B and the C can be the options. The B, you see, the image will be formed here. Let me take them and show you how this is done. You see, let me take them into the paint. The image is here. This image, this diagram is basically wrong. You see, the rays are converging, that is wrong. Diverging lens don't do this. Diverging lens don't do this. It's wrong. Converging lens, yes. But here the image will be here. This will be the image, and this image is real. This image is inverted, and this image looks the same size as that of the object, I think, or a little bit larger. Okay, if you look at this image, the image number D, let me show you. If I will prolong this line behind the mirror, and I will prolong this line behind the mirror, you see. So where they intersected each other, Wherever they have intersected each other, there the object will be formed. This will be the image will be formed. This image is virtual, this image is magnified. So I think D is the right option. It's the magnifying glass. This diagram is actually the diagram of the magnifying glass. So D is the right option. I hope you have understood. His question was, a converging glass lens is used to produce a virtual magnified image. Which ray diagram shows the ray passing through the converging lens? These two are straightforward wrong because they are not converging lenses. So B and D, they have the competition. So D is the right option. I showed you by the ray diagram that in the D option, the image formed will be virtual and will be magnified. So D is the right option according to our understanding. Question number 33, D is the right option. Okay, let's go to the next question. So question number 34. A metal lightning conductor is placed on the top of a tall building. The conductor is connected to earth. When a charged cloud passes over the building, the metal lightning conductor becomes positively charged. What happens to the lightning conductor to produce a positive charge at its top? You see, because this the bottom of this cloud is negative, so the electron from here they will be repelled and they will go into the ground. Okay, so what happens to the lightning conductor to produce a positive charge at its top? The electrons move downwards and protons move upward in the conductor. The electrons definitely move downward, but the protons do not move. So A cannot be the option. B, only electrons move in the conductor. That can be the answer. Only proton moves in the conductor. That is totally wrong. Protons in the air attract themselves to the conductor. That is also wrong. Only the electrons move in the conductor. That's the reason. Electrons have gone down into the ground. That's why the top has become positive. Question number 34. I think B is the best option. B is the best option, sir. Okay. Two insulated and uncharged metal sphere X and Y are touching. A positively charged rod is held near X and then the spheres are moved apart. X now has a negative charge. What is the charge on Y? You see, when you bring this positive charge, let me show you how this works. Let me take it into the paint. Okay. So here we will have, I think, when I will bring this positive here, this thing will be, this side will become negative and this side will become positive. You see, and what you did, you kept this charge rod here and then you separated it. Electrons from here, they have moved to this side because of this positive charge rod. So here a deficiency of electrons is created. So this looks like positive. Here excess of electrons, so that thing becomes negative. By keeping this charge rod in the same place, you separated them. So now they cannot go back. The electrons cannot go back. And then you remove this. So what will happen? This thing will become negative and this thing will become positive. I hope you have understood. So what is the charge on the Y? It will be positive. And the amount of positive on the Y will be equal to the amount of negative in the X. Positive and the same size as that of X. So D looks the best option. 35 For 35, D looks the right option, sir. For question number 35, D is the best option. Okay, next question 36. A stationary negative charge in an electric field experiences an electric force in the direction shown. What is the direction of the electric field? You see that direction. When you put a negative charge in an electric field, the negative charge will always move opposite to the direction of the electric field. If the electric field is going upward, the negative charge will go downward. If the electric field is going downward, the negative charge will go upward. The negative charge moves opposite to the direction of the electric field. So here the negative charge is moving towards right. So the direction of the electric field should be to the left, because the negative charge moves opposite to the direction of the electric field. So if the negative charge is moving to the right, the negative electric field should be to the left. So A looks the option, sir. Question number 36, A is the option. Question number 37, a metal wire of length L and cross-sectional area A has a resistance R. A second wire is made from the same metal. It has a length 2L and a cross-sectional area 4A. What is the resistance of the second wire? Let me show you. I have done this on a paper. This is question number 37. You see, the area was A and the length was L, so the resistance will be rho L by A. This rho is known as resistivity. L by A. This is the formula for the resistance. L stands for the length, A stands for the cross-sectional area. Then he says that the same material, if the material is same, then the resistivity will be also same. He says now the area is 4 times and the length is double. So let me find out the resistance. Resistance is equal to rho length divided by area. Length is 2L, area is 4A. So 2 divided by 4, take this to the side. So you will have rho L by A. Rho L by A is the previous resistance, the first resistance. 2 and 4 are cancelled, 1 by 2. So the new resistance will be half the resistance, half the first resistance. Very tricky question. I hope you have understood. Half the resistance. C is the right option, sir. C is the right option. I hope you have understood this. When the length has been doubled and the cross-sectional area has been 4 times greater, so the new resistance will be half the resistance which you previously have. The diagram shows a circuit. The diagram shows a circuit. What effect does, so you see here we have a battery, here I have ammeter connected, here we have a switch, here we have another ammeter. There are 2 resistances connected here in series with each other. What effect does closing a switch have on the reading of the ammeter X and Y? So when you will close this, you see when this is open, the loop of the current will be like this and going back. From here, the current will be coming, and from here, it will be going back. So it is experiencing two resistors which are equal, which are connected in series with each other. So their equivalent resistance will be more than the individual resistances. So the current coming from the the battery, that will be smaller because the resistance is higher. When the switch is opened, the 2 resistors and series, so their resistance will be higher. So the smaller amount of current will coming. At that moment, the value on the ammeter A, ammeter Y and the ammeter X will be same, because they both are connected in a single loop and in series. So they both will be actually showing the same reading. But when you close this switch, when you will closing this switch. So now suppose what will happen. Now, basically what you have done, you have short circuited it. So now the most of the current will be growing from here and then going back. So now these two will be kind of, I think, parallel to each other. So the resistance will become smaller. So the current coming from the battery will be larger, but that current will be not going through the Y. Most of the current will be going through the X. So the question is very simple. What effect does closing the switch have on the reading of the ammeter X and ammeter Y? The reading on the ammeter X, the reading on the ammeter Y definitely decreases. And the reading on the X should also, I think, it should increase a little bit. It's a little tricky question. Question number 38, I think increase, decrease, but let me check first. Question number 38, C is the right option. That's the option which I was trying to say. The reading on the ammeter X will increase because the most of the current will be going from here. The current like that path which has low resistance. So instead of going from here and here, the current will like this path which has less resistance, and you will close it. So the current will go and go back. So this reading on the Y will decrease and the reading on the X will increase. Before closing this, they have the same reading. But when you will close this, the X reading will be higher and the Y reading will be less. C is the option. Question number 39. A rectangular current carrying coil is pivoted between the poles of an electromagnet. Which action does not on its own increase the size of the turning effect exerted on the coil? Increasing the current in the coils of the electromagnet, that will increase. Increase the current in the rectangular coil, that will increasing the current in the increasing the current in the coils of the electromagnet, that will make the electromagnet stronger. So if the electromagnet is stronger, the turning effect will be stronger, it will be larger. Increasing the current in the rectangular coil, that definitely increases the turning effect, because if the larger amount of current is flowing through the coil, the turning effect produced will be larger. A and B, they are possible. But we are looking for which does not. Reversing the current in the electromagnet, it do not affect the amount of turning effect. It can affect the direction of in which direction the coil will be turning, but the size of the turning effect, no. So reversing the current in the electromagnet, it will have no effect on the size of the turning effect exerted on the coil. So C is the right option. Increase the number of turns on the rectangular coil, it will have the effect. So C is the right option. Reversing the current in the electromagnet will have no effect on the size of the turning effect. So C is the right option. Let me check. Question number 39. C is the right option. Okay. The diagram shows a coil connected to a very sensitive ammeter. Magnet is next to the coil. Which action results in a zero reading on the ammeter? You see, the diagram shows a coil connected to a very sensitive ammeter. The magnet is next to the coil. Which action results in a zero reading on the ammeter? If this will not move, if the magnet will not move relative to the coil, or coil will not move relative to the magnet, if they do not move relative to each other, no EMF will be induced. The EMF or the current or the voltage is produced in the coil only when the magnet or the coil, they move relative to each other. When they move relative to each other, then the magnetic lines of the magnet which are passing or which are cutting the coil, they change if they move to each other, if they move with respect to each other. If the coil and that thing will move relative to each other, the coil and the magnet, then what will happen? They will the magnetic flux passing through the coil will change and the EMF will be induced. So which action results in a zero reading on the ammeter? Moving the coil and the magnet at the same speed in opposite directions? No. When they will move in the opposite direction, the magnetic field will change. Moving the coil and the magnet at the same speed in the same. So you see, if this is magnet and this is the coil, if they move in the same direction at the same speed, relative to each other, they are not moving. If the coil and the magnet, they are moving in the same direction at the same speed, relative to each other, they are not moving. So that's why the no reading will be shown on the ammeter. So B is the choice. Let me check C also. Moving the coil away from the stationary magnet, that will definitely move EMF, produce EMF, induce EMF. Moving the magnet towards the stationary coil, that will definitely induce EMF and the deflection will be shown. The only possible answer is B. When the coil and the magnet, they will be moving at the same speed in the same direction, then that means relative to each other, they are not moving. If the both of them are moving in the same direction with the same speed, relative to each other, they are not moving. When relative to each other, magnet and the coil are not moving, no EMF is induced in the coil, and the ammeter will show zero deflection. So B is the option. Let me check. Yes, sir. B is the right option. So, my dear students, so we are done with this paper. This was May, June 2020. 1-2 paper. It's an MCQ paper. The subject we were studying is Physics 5054. And you know, this was 2020 paper, May, June. In this paper, it has some questions which are very, very tricky. And I plan them to make mistakes so you can understand that the students makes mistake. Because you know, if we are not to do this paper, you have to be mentally very, very present. You should be very focused and you should be catching the wording, what he's saying. Okay, so the most of the paper is easy, but 3 or 4 questions, they have a very tricky way of telling the information, so that the way they tell you the information, that can confuse you. So, okay, Ji, thank you very much, everybody. But I would like to say one thing. If you like this video and you are watching this video and this video has helped you, kindly subscribe my YouTube channel and also like my videos and give me a thumbs up and subscribe my channel, and also click the bell icon which is showing in the under this video. So I hope this is helpful to you. Kindly ask your friends to subscribe to my channel and get help on the subject of physics, O levels physics. So thank you very much, everybody, and have a good day. And God bless you all. Thank you.